Welcome to Chapter 5, 5.1 Gas. Now let us revise again what is the qualitative basic assumptions of the kinetic molecular theory of gases for an ideal gas. Kinetic molecular theory of gas. The theory states that a gas consists of tiny particles and negligible volume. The intermolecular forces of attraction do not exist between gas particles. The molecules of a gas are in continuous strengthened motion. Pressure is exerted when particles collide with walls. The collisions between gases, particles, and with walls are perfectly elastic. The average kinetic energy of the gas molecules is directly proportional to the absolute temperature in Kelvin. Okay, let us find out what is the definition for Boyle's law, Charles' law, and Avogadro's law. Now, I have asked someone in the group, to pass you three links regarding Boyle's law, Charles' law, and Avogadro's law. In the three YouTube videos, it will show the motions, or animation to help you to understand better of what is the meaning of Boyle's law, Charles' law, and Avogadro's law. Okay, the video is about 3 minutes only. Okay, after you watch your videos, come back to this statement or these definitions again. Okay, for example, let's look at Boyle's law. The Boyle's law states that the volume of a gas is inversely proportional to a gas in pressure. Okay, so in the definition, you must write down what is the fixed amount. That is number of moles, and then another one, constant at temperature. Okay, so you can see here volume is inversely proportional to gas pressure, where fixed amount of gas and temperature is constant. So the formula used will be P1 V1 equals to P2 V2. Okay, another one is Charles' law. Charles' law states that the volume of gas is directly proportional to temperature, must be in Kelvin. Okay, so what are the constant? That is the pressure and the number of moles, or the amount of gas. So the formula used is V1 T1 over V2 T2. Okay, the third one we will be using is Avogadro's law. That is, the volume of a gas is directly proportional to the number of mole of gas. So the other two will be constant, that is pressure and temperature. So remember, temperature must be in Kelvin for Charles' law. So you can look at these three laws. Okay, we are just using pressure, volume, temperature, and mole. Okay, so if any of the two variables that we're going to use, then the other two will be constant. Okay, so these are the parameters to describe gaseous states. Okay, there are many units that you can use. Okay. Now we are going to look at the graph. Okay, so just now we have learned that volume is indirectly proportional to pressure. So you are going to get a curve. Okay, so this is for Boyle's law. So you can plot graph according to your variables. Okay, for example, if you want to get a straight graph, linear graph, and pass through origin, then use P versus 1 over V. Okay, for Charles' law, you have to be extra careful because for Charles' law, you have to know where are you using degrees Celsius or Kelvin. Okay, if you are using degrees Celsius, then it must have intercept. Okay, especially at the absolute zero. Okay, that is negative 273 degrees Celsius. Okay, so it's the same thing again for Charles' law. For Charles' law, if you want to use a linear graph which passes through the origin, then you use volume versus temperature, but the unit must be in Kelvin. Degrees Celsius, intercept. Okay, just now we have learned about the gas law and the expression, and also some formulas for us to calculate. Okay, so now we go for some simple calculation involving the gas law. Okay, first of all, okay, let's look at the question. The initial pressure of the gas, and then after that, all the gases is transferred to vessel C. Calculates the new pressure. Okay, so we can see here means that initial pressure is 0.5. Okay, then the initial volume is 4.0. Okay, now next one, transferred to C means C becomes V2. Okay, V2 is 3.5. So we want to calculate the new pressure. So we can use Boyle's law. P1 V1 equals to P2 V2, and don't forget the unit. Okay, now Charles' law, you have to be extra careful. Okay, because the temperature you must convert it into Kelvin. Okay, in the question is given 25 degree Celsius. So you must change it to Kelvin. Okay, same thing again for Charles' law. E is the initial, F would be the final, okay, or we label it as V1, T1, V2, T2. Then by using the Charles law expression, then you can get the answer. The question didn't ask for degree Celsius or Kelvin, so you can choose either one. Okay, another one is Avogadro's law. Okay, for Avogadro laws, look at this question. This one says that at STP. So we know that at STP, okay, 1 mole of any gas occupies 22.4 liter at STP. Okay, so you just use the Avogadro's law, then you can find out the answer. Okay, so that's all for the 3 gas law. That is Boyle's law, Charles' law, and Avogadro's law.